So my view is that the preferred state is Mars full of life, and that life being a Martian genome distinct from Earth. So that's the preferred state. And it may be that there is a Martian genome, that it's been disassembled, and we need to reassemble it, and if so, we should do so. But it may also be that there is not a distinct Martian genome, that life on Earth and Mars share a common genome, at which point the question is moot. We don't have a possibility of having a Martian genome. There isn't one. And in fact, given what we know, that would be the assumption, that life on Mars and life on Earth share a common origin because of exchange between the two planets. It seems to me that that's a very important question to resolve before we start doing anything on Mars that's irreversible. There's an analogy in mathematics with NP problems and P problems, problems that are exponentially hard and problems that are only linearly hard. We think of contamination as exponentially hard because in most cases the organisms grow exponentially. On Mars, right now, nothing is growing, so the problem is not an exponential one. So everything we've done on Mars is, in principle, reversible because the contamination has not grown. And we ought to make sure that it stays that way. So it doesn't mean that we can't go to Mars or can't do things on Mars. We just have to be careful to not allow any contamination that's not biologically reversible. So I've been arguing that we should adopt a principle of biological reversibility, not sterility, which is impossible, impractical, and already too late, but biologically reversibility. Then we keep the option open as we continue to explore Mars in a biologically reversible way, including with humans, because we can do humans in a way that's biologically reversible as well. If we find Martian life, and it turns out to be related to us, then we just stop the reversibility, we all move in, it's just cousins on another planet. If we find Martian life and it turns out to be a separate genome, then we say, okay, show's over, everybody leave, collect all the microorganisms, all the spacecraft that have been there before, and either sterilize them in situ or bring them back to Earth, put them in museums. Either way, we reverse the contamination, and then we restore Mars to life, restore the genome, and have Mars full of Martians. The utilitarian reason is that the most important technology we have right now is biotechnology. It will have the biggest influence on our quality of life and our ability to produce food, pest control. Just look at one simple example, bacterial infection. Think how many people are killed from bacterial infections. And even when we think we have antibiotics that can control, it is a huge issue. Think of the challenge of producing food. Think of medicine. Think of cancer. All of these issues that now face us are biotechnological in basis. The simple physics problems have all been solved. We know how to make electricity. We know how to warm our houses. The challenges that we face in improving human quality of life and improving the quality of the Earth as a habitat for life and maintaining Earth as a habitat for life all are rooted in biotechnology. That's why you guys are all in SynBio. All of our biotechnology is based on one data point, one example of how to do life with DNA and ribosomes and codons. All one. It's we only write books in English. We only have one language, one representation, one way of turning concepts into a biological reality. Now maybe, and some people have argued, this is the only way to do it. There is no other way. No matter that, everyone in the universe speaks English because it's the only language. And that no matter where you start, you're going to end up on the same point with the same biochemistry, the same point in some sort of complex phase space. If we go to Mars and we find that there's a different type of life that's using a different coding system or a different translation system or different in some independent way and represents a separate origin of life, suddenly now we have two types of biochemistry. Right? So instead of a book called Biochemistry, we could have a book called Biochemistries, Chapter 1, Earth Biochemistry, Chapter 2, Martian Biochemistry, Chapter 3, whatever. Right? And that might be incredibly important to be able to see different ways of seeing how things are done. And I reflect on my own history. I was born speaking English, and I never really got into understanding English as a language until I took French in high school. And it was studying languages, French, and comparing it to English that I suddenly started to understand things like verbs and nouns and tense. As a kid, I never understood them because I just used them. I didn't understand English, I just knew how to use it. I only understood English by studying French. And so I contend that there's a lot of questions in biochemistry that we will never understand as long as we only have one example. And that those questions are not just trivial academic questions, they're questions as fundamental as why are the only microorganisms that are pathogenic bacteria and not archaea? Why are there no archaea that are pathogenic? They live in us, they're in our gut, they're everywhere that bacteria are. They are more closely related to us on the tree of life, and yet there's no pathogenic archaea, there's only pathogenic bacteria. Why is that? That may be a question that we'll never really understand unless we have more than one tree of life to compare to. So I would argue that from a purely human knowledge, improving important technology, quality of life, etc., having a Martian genome fully represented and functioning on a Martian planet is much more valuable to us than anything else. So from a purely utilitarian point of view, I would argue we should enhance, preserve, and support a Martian genesis if there is one. I also personally, not scientifically, personally think that there's an ethical reason to preserve a Martian genesis as well, and that is that we should value richness and diversity of life in the universe. And so if there's a Martian genesis, it represents a enhancement of the richness and diversity of life in the universe, and we should support that. But I appreciate that that second argument is a personal one, not a scientific one, and many people would reject that and say that the only value that we should place on the universe is not enhance the richness and diversity of life, but enhance human well-being at the expense of all other forms of life. At which point they would say we should not preserve a Martian genesis just for its own sake. And that's why I give the utilitarian argument first, because that argument says, from a purely selfish human point of view, our best interest is served by preserving that and enhancing that Martian genesis and letting it represent itself into a full biosphere because of the potential information we might gain from being able to study that. It depends on how you interpret intrinsic value. There's two ways I've seen it interpreted. The notion that life has value sometimes been interpreted to mean that we should not interfere. So the universe has a big sign on it that says, do not touch, which means we don't help, we don't hurt. So if there's life on Mars, we quarantine it and we neither help nor hurt that life, we just leave it alone. But I think that view is incorrect. I think the view, there's nothing wrong with us trying to help. And I think we all understand this intuitively. If we're walking down the road and we see an animal stuck in, let's say we see a rabbit stuck in a tar pit, right? And we know that if we put a stick down, the rabbit could bite on the stick and we could pull it out of the tar pit. We would. Mm-hmm. And no one would agree that that is a bad thing to do. Right? Even though we've interfered with the natural course of events, we have rescued that rabbit from its natural death. And the reason is because we understand the situation completely and we know that what we were doing would help the rabbit. Right? And we take that action and we know that there would be no untoward consequences. So that to me is a proof in principle that helping is allowed. That the notion that we should never help other life forms is ethically weak. But in order to do that, we have to understand what we're doing, because we have to worry about unintended consequences and the possibility that in the long run what we think is helping is actually hurting. Right? So when we find life on Mars, I think we should take the attitude that yes, we're from the government, we're here to help, but we should be very careful to understand the situation so that we know how help can be best applied. On Earth, the question would be very hard to answer because Earth is so complex and there's so many different ways life can be hidden or its evidence could be hidden. On Mars, I think the problem is a simpler one. And I can answer that question in terms of my own interest. I can say, at what point would I conclude that there's very little chance that there's life on Mars? And I think the answer is if we had obtained a core from the polar regions, a deep core from the polar regions, and failed to find any evidence of life in that core. And that core did, as we think it would, reflect the Martian history. Because unlike Earth, Mars lacks plate tectonics, and so stuff is just piled up on the surface. So we can fairly readily get to material that's 3.5 billion years old. And in the polar regions, that material is piled up and is frozen. And so there are places on Mars, particularly in the south polar region, where we might reasonably expect to be able to drill a core a couple kilometers and find record of Martian environments all the way back to 4.5 billion years ago. And if indeed we do drill such a core, and if indeed we find geological evidence that it does stretch back over the long reach of Martian time, and in that core we don't find any evidence for life, then I, for one, would be willing to say, okay, this planet is, for all intents and purposes, lifeless. The notion that other planets become a substitute for Earth or a place you go to after we've wrecked the Earth, I think that is ethically absurd. It's a bad view to take from an ethical point of view. But even setting aside ethics, it's from a practical point of view, it's absurd. We can't think of Mars as a lifeboat for Earth, because the principle of a lifeboat is that you've got enough seats in the lifeboat that everybody on the boat can get a seat in the lifeboats. There's no way we could launch 6 billion humans into space. So it's not at all a practical lifeboat system. So, well, maybe it's just a preserve the genome. You just send a few representatives. But if your goal was to preserve the genome of humans against some disaster, and you started from that goal, it's not clear to me that the answer would be to build a colony on Mars. Right? It probably would not be. It'd probably be more like the seed bank thing that they're building up in Norway. Right? You would start with what are the potential disaster scenarios, and what can I do to most effectively preserve the largest diversity of genetic information. And if you start from that problem, you don't get, oh, the answer is build a colony on Mars. What people do is they start from, I want a colony on Mars, how do I justify it? Well, one answer is, well, it's a genetic lifeboat for life on Earth. But that's starting from the answer and then working backwards. So I reject completely the notion that Mars is a backup to Earth, a lifeboat for Earth, or a genetic safety valve for Earth. I think that technically makes no sense, and it's ethically absurd. We have to take the position that when it comes to Earth, failure is not an option, to coin or to use another NASA phrase. Failure is not an option. We have to take care of Earth. So I see humans, the capability of humans, things like synthetic biology, as the necessary tools to take care of Earth. And we want to take care of Earth in a way that does not require us to reduce the quality of human life or human experience or human culture. I don't think that it's incompatible to have a healthy Earth and a healthy, vibrant human culture. So we just need to make that so. And I think synthetic biology is one of the tools we have to use to make it so.